This is part 3 of solving systems of equations by elimination. In these examples, what we have to be aware is that this is a -4 in front of the x and a -3 in front of the x. And in front of the y is a +8 and a -9. Now, we can't multiply any one of these equations to make it equal the other one. Like I can't multiply -3 by something to give it to be -4, and I can't multiply anything by -9 to make it +8. So when you get into this scenario, I normally just look at my x's, okay? And I ask myself, what would um, what would be a number that both 3 and 4 um, could could go into or be multiplied to make and everything. So 12 is what I've come up with. So what I'm going to do is I'm going to multiply the top one by -3, and then I'll multiply the bottom one by +4. Now, what that's going to do for me is a couple of things. When I multiply this 3, I'm multiplying everything by it. So -3 times -4, so it's going to be here, right? And then all the way over there as well. So 12x minus 24y equals, well, that would be -48. Now, when you multiply the bottom one by 4, every bit of that's going to be multiplied by 4. So that gives me -12x minus 36y equals -12. Now, what you should see here is that we have a +12x and a -12x. These, when added together, will eliminate and will give us -60y equals -60. And of course, you should be able to see what's going to happen next. We'll divide both sides by -60. So y equals a negative gives me a positive, and 60 over 60 is just 1. So we found that y is equal to 1. What you can do now is either plug the y 1 in for y in the top equation or the bottom equation. So I'm going to plug it in this equation down here. So -3x what to put equals, but -3x minus 9 times 1 equals -3. So -3x minus 9 equals -3. That's +9. So basically what I've got right here, and I'm going to bring it up here, is -3x, I got a 3, equals, that's 9, and that's 9. So -3 plus 9 is +6. Divide both sides by -3. So I get x equals -2. So that answer is -2 comma 1. -2 comma 1. So let's kind of recap. I had it two equations. I couldn't just multiply one to get a coefficient of the opposite side of the other. So I had to multiply both equations. And the ones that I tried to eliminate was the x because it's sitting right here up front, and that's the easiest one to do. Now let's look at 6. Okay. I've got 20x and -8x. Well, I know that both of these can go into 40. Okay. So what I'll do is I'll multiply the top one by 5, and then I'll multiply the bottom one by 2. So let's show you what we've got. We've got -40x minus 60y equals 20. And We have 40x plus 60y equals negative 20. Now, we're going to add those together. Negative 40x and positive 40x gives me 0. Negative 60y and positive 60y gives me 0. Okay, so stop right here, because what you need to consider is this. Both of my variables have dropped. Now, that means that I'm either looking at parallel lines or I'm looking at the same lines. Now, let's kind of see what's left. So equal 20 minus 20 is 0. What I'm left with now is 0 equal to 0, which means the left side equals the right side. So therefore, these equations, linear equations, are really the equation of the same line, which means that we have infinite amount of solutions, or basically infinite solutions. Either one is fine, but you need to understand that that's what happens when your variables drop. You either get a parallel lines, which means your left side does not equal your right side as far as the numbers left, or you get the left side equaling the right side, which is what happened here, and we get infinite amount of solutions. This concludes part 3 of solving systems by elimination.